local waste to local energy, and biofuel solutions. Our ability to do more distributed energy and not be moving waste around long distances. And that's something that we're very interested in and able to support. Incidentally, the plant you see here on the front cover is located in Croatia, and we're in the process of recommissioning that right now. So I've already commented on a number of things here. I guess I'd like to stress that we are a technology company. So like an Intel or a Microsoft, we are not, developing or deploying or running our own plants, except by exception. We do have a handful of plants that we are actively involved in supporting through operations, O&M, on an ongoing basis. But that's predominantly to have showcase facilities at commercial scale where we can take prospective customers and stakeholders and share with them what the technology operates like in live environments. But as I say, that's an exception. We see large owner operators, whether they be industrial companies such as Toyota, we're working with here in the UK, who would want to build facilities that take their waste and return it to them as value, whether that be in the form of fuel or thermal energy to run industrial processes or electrical power. We also want to work with the large utility companies who see this as a way of decarbonizing their current footprint, but also moving on then and building new lines of business with this technology as a solution. And then, of course, we also have infrastructure funds and so on who want to invest in portfolios of these plants. So we're the technology company that supplies those technology solutions. I said we're baseload. We're also extremely versatile, both in terms of the feedstocks that we can take municipal solid waste amongst them, but also industrial waste and sludge, and a wide range of agricultural, forestry, and other industrial and municipal wastes. I'm happy to share a list with you of the feedstocks we've tested, but we have a growing library of feedstocks. And with our ability to do computational modeling of the behavior of those feedstocks inside the gasification reactor, and then all the way through our process, we are able to fast track some of the design based on how people want to use various types of waste. We also have quite a lot of versatility in terms of offtake. I mentioned the range of offtakes that we can do. We produce a synthesis gas or a SIG gas that I'll come on and talk about, in which I think many of you will already be familiar with. I mentioned that we're clean, and I'll say a bit more about that later. We're also proven, and I think unlike many gasification technologies, of which ours is one, gasification has struggled to succeed at commercial scale. We have had a plant now running for 11 years in the south of Spain. It's been operating at 90% plus operational availability, and therefore creating a very good commercial basis for operational basis for the commercial model of that plant. We have a range of others that I'll come on and talk about as well. We're growing as a business. We have no issue with demand. We have more demand than we can service given our current size and stage of development. But we're operating in 7 markets actively, one of which is the US, but exclusively so far in California. And finally, we're commercial. And what I mean by that is, like some others, but not all, we're not coming at this purely from an engineering and technical excellence perspective. We absolutely are deeply involved in the financial and economic modeling of this to ensure that the plants that hold our technology are sustainable for the long term and able to deliver consistent value year on year. We are not developers, but we work very closely with them, and we guarantee operating hours at 7,500 hours per year. So that's roughly 86% operational availability. We know of very few, if any, other technology companies who will put those kinds of performance guarantees on what they do. I should also say that those are insurance backed. So we have 2 reinsurers who are willing to put insurance backing to those performance guarantees. And we need that given that we're not world famous quite yet. Syngas, for those of you unfamiliar, is effectively composed predominantly of 4 things, one of which is methane, the second of which is hydrogen, and then we have carbon dioxide and carbon monoxide. Synthesis gas serves as an intermediate fuel. That is to say, very rarely is it used directly to power other things, although we have had a few of those discussions. But because it is produced from waste, this makes it extremely valuable. A blast furnace in a steel company or various other forms of coal gasification have been around for decades. What's been far more difficult is to create a very efficient and clean process to produce synthesis gas from less calorific inputs, such as various types of waste. Some being more calorific than others, but almost all being less calorific than, for example, coal. So what we've been able to do is create a very efficient process. And as I'll show you later, what really does differentiate us is that we design and we manufacture to the whole process. We're not simply providing a single piece of equipment. That also gives us a range then of offtakes we can produce from that intermediate fuel through other processes. And so we partner with the likes of Wood, for example, the engineering group, to help us do the methanation that would create a renewable or synthetic natural gas, which is a full replacement for natural gas that you would otherwise pull from the ground. We do the same with hydrogen, and we have other partners for liquid fuels. We now have partners for methanol as well. And as I mentioned, we can produce biochar in addition to electrical and thermal energy. I won't go into all of us. I'll actually focus here on, there are 4 executive directors in our company. The CTO is the inventor of the technology. He is heavily invested in and very much sees this company as his vehicle for taking this technology to market. He's been involved with gasification since 1997. He has a PhD, of course, in chemical engineering with a focus in gasification. And we now have 4 PhDs, all of which have chemical engineering degrees with focus in gasification. We've got about 20 now engineers based in Barcelona, Spain, where we have our technical center. And Joel Aleman, the CTO, has been long advising a wide range of companies, some of whom I think are actually working in your state. So as I move into the technology, I think the thing I'd want to highlight is what I said earlier about the fact that we've been operating now for 11 years at 90% plus operational uptime, which again, we think is quite rare in this market. We've clocked 120,000 plus operating hours. And of course, that kind of technological performance, but also the versatility creates greater commercial viability for any of these models. And we underpin that with performance guarantees of 7,500 hours. This is our technology on a page. You can see on the left the feedstocks, and you can see on the right the various types of offtake applications that we can support. In the middle, you'll see 3 key vessels, all of which we have patents on. The first of which is the gasification reactor itself. The second of which is the hot gas conditioning, or what we call the thermal cracking reactor, which effectively removes the hydrocarbons. And then the final thing is the cold gas conditioning, which is a water scrubber that removes the water-soluble chemicals, the chlorines, the potassiums, the sulfurs, and so on, that can detract from the efficiency of the synthesis gas and therefore make it less valuable or even problematic downstream for other applications. The other thing we have a patent on is the end-to-end process and how we've designed that process. And because we're involved in the entirety of that process, from feedstock input to synthesis gas output, we are able to create feedback loops, such as we do with the hydrocarbons coming out. We recycle those back through the gasification reactor. We can trade off various temperatures as well as a way of breaking those down and removing them. And that allows us to get an extremely pure synthesis gas. If you're familiar with Jenbacher, the gas engine company, they've gone in writing to say they've never seen a purer synthesis gas than the one we're able to produce. That allows us, therefore, to plug straight into a gas engine rather than going again through a boiler. So we can plug our process straight into a gas engine that, again, powers a generator to create electricity. It also is extremely important for advanced gasification applications, such as hydrogen and liquid biofuels and so on. Part of the other reason that we're able to do that is because the control systems are also proprietary technology, and we program all of them in-house. So this is effectively the software that runs this process. and monitors the process and responds to and reacts to that process. So again, because we can know what's happening, we're able to react to that, and the control system can automatically react to that. So we don't outsource that to a Siemens or another company to run that. We do all of that in-house. And I also mentioned earlier, we have a computational modeling capability so that we can create this and design this process end to end before we send any specification for manufacturing. And that is it's been proven again and again to be a highly accurate model for this. If you're familiar with Aspen Tech, which is a very common software for looking at thermochemical conversion processes, we use Aspen Tech for the hot gas conditioning and the cold gas conditioning. But we're very few, if any, companies we know of have any proprietary capability. It's an understanding what happens micron by micron inside of the gasification reactor. That is where our model really comes to the fore, because we can understand how to manage that efficiently.
Jeff? Please. Just so that you know, we're trying to keep this to an hour. So I know you have more slides, and I want to be able to get through them all and give people time for questions. Just for planning purposes is all. Thank you.
Perfect. Thank you. I appreciate that. So with that in mind, I'll move on. That is our technology, as I say, on a page, and some of the things that we think differentiate us. We can, as I've said, we work with wood. So we can plug in, as one example, their methanation process, which would then allow us to produce synthetic or renewable natural gas. We can do the same for hydrogen. And you can see here the kind of synthesis gas composition we can produce for things like hydrogen with only trace hydrocarbons left in the syngas. I mentioned that we're clean. We have a very low greenhouse gas footprint. If you compare us to a lot of the alternatives, whether that be best-in-class incineration, or what you see over here in Europe as the EU average for incineration, and indeed several others that don't work on the waste side of the equation at all, we are extremely attractive in terms of being clean. Because the gasification process by its nature does not burn, there is no combustion, we don't produce some of the nitrous oxides or the toxic dioxins or furans, and we don't produce fly ash and so on. Other than the synthesis gas, the only other significant output from the process is a non-hazardous bottom ash. And in fact, that ash can be reused in industry, for example, in the cement or the steel industry. So I mentioned earlier business models. These are 4 business models where we are currently producing what we call market development centers, or these kind of showcase plants. We're producing one for each of the business models. And in fact, we're due to start commissioning one now in Italy right now. I was just there for the past 2 days, and we're commissioning it as we speak. So we have, first of all, an industrial model, which is the idea of serving, as I mentioned earlier with Toyota, a specific industry where there's a circular view where they want to take their waste and they want to capture the energy or the value from that. Municipal is a big one, as I mentioned. We can produce larger scale plants, and in fact, we have some like that, but we can also produce small scale localized plants. So rather than taking the waste and having to centralize it into regional hubs, you leave it locally, you process it locally, you deliver the value locally. And again, we're doing a project that will prove that as well. Agricultural is what we're doing in Italy. That's about reaching remote agricultural locations where they do have waste that they have to otherwise pay to get rid of. We buy that from them. We then process it through, and we return. In this case, it'll be electricity and thermal energy, and also biochar, all of which can be used for agricultural purposes. And then finally, we have the utility model, which is for the power companies and the energy companies who want to do this as part of their portfolio. And all of these, we've got several projects in the pipeline to support. So I think the last big thing that I wanted to comment on, and then I can, maybe get a view from you on where you're more or less interested, and I can then, pick the case studies that we kind of deep dive into, was to tell you a bit about our track record. So I mentioned that we've had a plant up and running for 11 years. It is what we call the Movialsa plant in southern Spain. Its startup was in 2011. And it's roughly a 6 megawatt electricity, but also it's a thermal energy now plant as well. It is on site on a very large agro-industrial facility. So this is one of the largest olive oil and olive product producers in Europe. And they have a problem that many companies around the Mediterranean have, which is the treatment of olive pomace. Olive pomace has very high potassium content, and it's a very difficult feedstock. You can't put it into landfill because it makes the land, unarable. It makes it difficult to grow anything else there. So on that basis, you have all this olive production, and they have to get rid of that waste. We also have wine must, which is what's left over from when you squeeze the juice out of the grapes. So a very high humidity content and so on. Both of these things go into the same gasification process. We can take different feedstocks and put them into the same process. And I'm happy to tell you some other stories of plants where we're putting municipal waste and other types of, for example, construction waste and demolition waste all into the same gasification process. Because we run the whole process, we can take that and accommodate that. So as I mentioned, the plant has been up and running for large periods of the year. And if you look at the electricity feedstock ratio, sort of the conversion ratio here, what you'll see is a 1 to 1.4 ratio, which means that for every ton of feedstock that comes in the front of the process, you're getting 1.4 megawatts equivalent of electrical equivalent coming out the other side. That is much higher than what we typically see in many other processes that would be comparable in, from the incineration sector and so on. So in addition to this being a clean process, it's a highly efficient one. I would argue because it's efficient, it's also a clean process. We've also built 2 R&D facilities that are very active, particularly the one in France, which now does steam oxygen gasification, which is again critical for advanced gasification applications. And that we are regularly running tests on. And then there are 3 others that we have built that were decommissioned, not because of technology reasons, but because the economic model was done based on subsidies by the owner operator. So the subsidies were consequently pulled by the government, and they were unable to continue. We have purchased now the first 2 of those, and we are now in the process of recommissioning. And the one you see here in Italy is the one that I've just come back from that I mentioned. And so again, against each of those 4 business models, we have a pipeline of work, at the head of which, at the top of which, is what we call the Market Development Center in various parts of the world. And then we've got a range of things we're doing beyond that. We have, for example, another plant that does contaminated plastics. And when I say contaminated, yes, we can do food contamination, but in this case, this is chemical and fossil fuel contamination. So this is when you buy motor oil at the local gas station and you put it in your car. Even if you clean out that plastic container, there will still be fossil fuel or chemicals that are embedded in the plastic material. And it's very difficult to treat that. You can imagine there's a very high tipping fee for that over here in the hundreds of euros per ton. And there are a range of other wastes that we're doing. And as I say, we're mixing wastes as well. So I'm very happy to talk more about that. So all that I have after this, aside from my own questions for Connecticut, are some case studies, some very specific case studies. This is one we shared previously with some of your colleagues, but why don't I pause there and see if there are any questions that I can pick up. And if you've got interesting case studies, I'm happy to go into those.
Thank you, Jeff. If you would bear with me, I have a couple of questions myself. And one of the things you mentioned was the subsidies provided by the government being removed. So let me ask you, is there a specific kilowatt per hour charge rate that you would need in order to make constructing a facility like yours in Connecticut worth it, economically viable?
No, it's a good question. It's difficult well, first of all, let me just talk about the tariff, or what I would call the tariff in general. I mean, tariffs vary. But for us, the tariff is one variable in our overall financial modeling, of course. And for example, with municipal solid waste in particular, it's a trade-off between what the owner-operator of the plant will get as a tariff versus what they're getting as a tipping fee. And so there has to be a forecast for what those tipping fees are going to do over time, and then what the tariffs might do over time. Both are crucially important to what we look at. The other key variables, of course, are the operational availability, which, as I've said, we guarantee as 86%, which is extremely high. So I think our ability to accommodate, trade-offs on those two things is relatively higher. The problem with the subsidies in particular was that they didn't last beyond 2 or 3 years. That was the problem. And of course, they had built them into a 25-year model. And so it completely threw off the economics. So I'm sorry I can't answer your question with a specific number, but all of that would be factored into how we do this. And I think I'd have to look at some of the other variables in play to answer your question fully.
Thank you, Jeff. And a reminder to everyone else, if you have a question, just put your hand up so I don't monopolize everything. But my other question is the state of Connecticut in our Department of Energy and Environmental Protection is very interested in diverting food scraps from our municipal solid waste. And if that, we have a pilot program going on now. Municipalities are responding. Some municipalities are interested. If food scraps were to be removed from your feedstock, what does it do to your like your syngas formula or anything along those lines? Does it become a deal breaker?
No, not at all. Thanks. It's a great question, actually, and it's one that's very important for us. And first, I think roughly a third of the waste now in Connecticut, as I read from the DEEP presentation, is either food waste or other organics. You can put them into the gasification process. Typically, we will want to get them to a humidity content that makes it more efficient in the process. And it's not so much that the process can't handle it. It's just to maximize the efficiency, we'd want to dry that. And so we sometimes can do that. But the other thing that we're doing, and the page I have up right now is a good demonstration of that, is we're partnering with Energia, whom again, some of you might know, it's a Canadian anaerobic digestion company, because the biogenics or the food waste, the organics that come out of municipal solid waste, we are separating through actually Energia's technology and sending to them. Well, that leaves us, obviously we remove recyclables because that is the best possible reuse of those, is to send them for recycling, metals, glass, and so on. And then the remainder, which has a lot of plastic and other content in it, we're putting into the gasifier. Now, we love plastics because they have a very high calorific value. And so therefore, a lot, anything that is of plastic content, polymers, resins, so on, we can put into the gasification process very successfully. So on the contrary, we have 2 projects with Energia, both of which will remove the food waste, send it to the digesters, and then everything other than the recyclables, obviously, left over goes into the gasification process.
Thank you. And then this is my last question, and then we'll go to Mark for his question. But so if the scenario I'm going to relay here is, let's say that we consider locating your facility where the now shuttered Mira plant is in Hartford. One of the objections to that is going to be that the city has hosted the plant there for quite a number of decades, and there are environmental justice issues that come up with the neighbors being subjected to the effluent from or the smoke, for lack of a better term, from the facility, and which is a valid point. So how would you answer that concern?
Yeah, no, it's a concern, of course. where we have a lot of work to do, to be honest, in terms of driving awareness around this. I mean, the first very clear thing is to say that, as I mentioned earlier, we do not incinerate. So we are not burning anything. There's no, nothing reaches combustion point. The thermochemical conversion process that we run is fully contained. And so if I give you the example of what we're doing right now in Italy, I was just talking with the authorities at the local level yesterday about this. The only emissions that are anywhere near legal concern at that plant, and the EU regulations around this, I dare say, are in general, more stringent than most places in the world. The only ones that come close are the emissions from the engine, the gas engine, which is not Ecotech technology. So that is to say, we don't emit anything really that's of concern. And if you'll allow me, I'll just skip ahead here to our municipal example in this slide deck, if you get a chance to look. The plant we're building in Southport, which is in the northwest of the UK, near Liverpool, you can see on the far left, it's a dump right now. So all the municipal waste is simply dumped there. This is in the middle of a green, leafy neighborhood with tree-lined streets. And it's the very end of that, and on the other side of that is agricultural land, is farmland. And so this is in the middle, and that's what it looks like. When we're done, all of that waste will be contained. And again, this will be a dual anaerobic digestion gasification facility. And this will remain in that leafy green neighborhood, but the residents will not smell, they will not see anything in the air, and they will certainly not get anything put into the water. So I'm very eager to get this up and running, again, as an example of how we can exist even in a green neighborhood with the residents, and have them feel not only that it's not a problem, but that it's a dramatic improvement over what was there before.
Thank you, Jeff. And as promised, I'm going to segue over to Mark. Mark has a question for you, Jeff.
Thank you, Mr. Chairman. Jeff, thank you very much for the presentation. Just a couple of quick questions on scale. I noticed the scale is in metric tons all over the place. Is there a minimum and a maximum to what you could scale to?
Yeah, thanks for asking. I mean, technically, no, because we can replicate lines, as often as you want. So, for example, we're building a 10 megawatt industrial. If you wanted to have 10 of those to do 100 megawatts, we can do that kind of thing. And there's probably efficiencies to be gained on sharing of single gasifiers with multiple, engines or whatever else you want to do. Having said that, it's the economics that come into question, which is, really going back to the chairman's question earlier, to what extent, are we getting a tipping fee and or a tariff that supports the expense, the capex on the front end, and the writing down of the capex along with the ongoing opex of the bigger plants. So the sweet spot we typically say is between 1 megawatt and 30 megawatt for our technology. Having said that, we haven't built anything bigger than yet, and we haven't even run a financial model for anything bigger than that yet. But that's typically where we focus.
And typically, your feedstock is delivered in trucks in a pit, some sort of sorting, and then processed. Would that be correct?
Exactly right. I mean, depending. I mean, there are instances where we don't need to sort, but that really depends on how it arrives. In the case of MSW, almost certainly, we're going to have some kind of sorting on the front end.
So in terms of your takeoff, I guess you're just technology, but from a business model, the hydrogen and the other takeoffs, are they susceptible, I'm assuming, to the commodity markets?
Yeah, absolutely. And again, that plays back to my earlier point, which is you need a purity of the synthesis gas to maximize the methane or the hydrogen. An example I put in the slides here, there's a hydrogen example. We can get to the point in the example I gave where about 1/3 of the synthesis gas is pure hydrogen. We're effectively dialing that up. If you're after renewable natural gas, we change the process to maximize the methane component. We can get that to maybe 40%. And forgive me, I'm just going to go back to your first question, Mark, because I'm aware you asked about, I think, tonnage, and I gave you a megawatt answer. In terms of tonnage, the Italy facility, I think, is only 7,000 or 8,000 metric tons per year. Our largest plant, the 25 megawatt that I mentioned right now, is 200,000 tons per year. So that gives you the tonnage. I'm sorry I didn't answer that as you asked it.
And I appreciate you going back to that. Last question would be resources in terms of power consumption and water consumption, and anything else that would be needed in this process.
Yeah, again, pleased to answer that. Let's start with power. In terms of power, this is something, again, we're talking to a big owner operator in the US right now about this very thing. They're interested in the hydrogen, but the problem they have is if you do electrolysis, as you know, it takes a huge amount of power from a fossil fuel driven grid. So it's not particularly green. So what they've done is they put photovoltaics down, but then you need a huge amount of land to run that. In our case, our process is autothermic, and we also take a certain amount of the power as typically it's around 10 to 15% of that power to run the plant. So once you get the startup, and you can start it up with a generator, you could remove it and it goes and it runs continuously, supplying its own heat and power to be able to run, which is, again, quite important if you want to run a very green operation. So it's really a question of how much of that power production do you want to put back into the plant. In terms of the water consumption, I'm afraid I don't have numbers for you, but I can go and get some. We do need water for things like, for example, if we need to dry any of the feedstock, or we need to do any of that, we can take the processed water from the facility, but there would need to be a water supply going into there in some way. But in terms of real numbers, I'm afraid I would have to follow up offline for you.
Thank you very much. I'd open it up to other questions.
Thank you, Mark. We're going to go to Brian Paganini and then followed by Frank Antonacci.
Thank you, Mr. Chairman, and Jeff, thank you for your time and this highly informative presentation here today. My questions are focused a little bit more on specifics relative to the feedstock that I think is most germane to this conversation, which is municipal solid waste here in the state of Connecticut. Obviously, seeing the experience in the Spanish facility and the feedstock inputs of olive pomace and wine must, can you talk a little bit about what we may perceive as a critical sort of pre-processing step into EQ-Tech's gasification system, and talk about does EQ-Tech provide free treatment of municipal solid waste, and your experience and EQ-Tech's experience in treating municipal solid waste into your thermochemical exchange process?
Yeah, happy to, Brian. It's a great question. The first thing to say very straight up is we do not have a functioning plant right now that processes municipal waste. So the projects I'm showing you are under development, and some very close to financial close, and then we will build them. And you can imagine, in a hurry to do so, because we have very strong confidence in our ability to do this. And I should add that our CTO has built municipal waste plants in the past using some of these aspects of technology through gasification. So that's the first thing to clarify. The second thing to say is, in terms of our role in the pre-treatment, we don't specialize in sorting. We don't specialize in production, for example, of RDF, which we would not want to buy and transport. We would prefer to have it produced on site. The example I have on the screen now and the one I showed previous, we would have a facility. Let me give the examples with working with Energia. The municipal solid waste will be dumped on site as is directly from the waste management company. That municipal solid waste would then be sorted for recyclables. The recyclables would be sent off site to a recycling facility. What remains, therefore, are effectively the biogenics, the food waste, the other organics that can go to the anaerobic digestion. Energia also have a technology then that would do that separation. They would then take the biogenics, send them to their digesters, and then remnants of organic waste and so on that were left would be of no concern. But the plastics and the other materials left over from municipal waste would then go into an RDF production facility. And that will produce, in this case, fluff RDF. And we do that again for the efficiency of the process, because dumping that straight into the gasifier just isn't going to return the same level of efficiency. So that's typically the way that we would prefer to do it. And that's what we're aiming for right now. There may be other alternatives in the future, but that's kind of where our thinking is. Did I answer your question?
Yeah, very much so. Thank you. And just to dovetail on that, coming from the facility operations world, guarantees and process guarantees are extremely important to any project, right? So when you say 86% guarantee, 86% uptime, is that relative to the tip to toes facility, i.e. The pre-processing, gasification, syngas production, biochar creation? I see you have a pretty robust what we'll call integrations team here with Wood and some other folks like Energia. Does EQTech offer that process guarantee, that uptime guarantee from the start to the end of the process, or is it just specific to the gasification step?
No, again, it's a really good specific question. I mean, I'm going to have to confirm that offline, because I'm of two minds. I mean, what I can tell you is that the 90% plus I was giving you was end-to-end, including the gas engines, which of course are not EQTech. They're a Jenbacher technology, actually. Sure. They're not EQTech technology. And most of the downtime of that plant, I can tell you, is servicing those engines. So that's the irony of it. However, the notion that we're going to give performance guarantees beyond the scope of our technology doesn't sound right to me. So I think, you know, I'll go and have another look at how we've set the contracts. The other thing I will comment, and it comes in both of the questions you've asked so far, is our ability to handle variability on the front end is quite critical. I mean, given your background, I mean, you will know that a lot of owner operators are trying to contract with feedstock providers for a very specific specification of feedstock. And there are even, you know, court cases when they go out of line. We don't believe that somebody who guarantees a feedstock quality can easily stay within the boundaries, you know, tight boundaries. It's not the real world as we've experienced it. So again, we design for a very wide variability. And as I gave the example earlier, we're doing a plant now in France. Again, it's not up and running yet, but that will take waste wood from demolition, contaminated waste wood, including, you know, chemicals and varnishes and paints and so on, but also RDF, all into the same gasifier. And we can accommodate that variation because we're doing the end-to-end process and the control systems and so on. But that again helps with the performance guarantees. But once we've given that, even on that wide variation from feedstock through to syngas production, that's where we're providing the guarantee.
Great. Jeff, thank you for your time and your answers. Mr. Chairman, thanks for the opportunity to ask some questions here.
Yeah, sure thing, Brian. Next, we're going to go to Frank Antonacci. Thanks, Frank.
Thank you, Chairman, and thank you, Jeff, for this really professional and informative presentation. You know, I think that Brian did a good job kind of bringing us back to what the chairman led off with, is that the reason why we're having much of this discussion is because of the mirror-generated closure and what we're going to do with MSW. I think what I take immediately from this is that what I think many of us as operators hold to be true is that very rarely is there a single silver bullet solution for different feedstocks. And I think you did a great job illustrating how you look at actually every different feedstock and design plants to tailor to them. It is exciting to see that you are studying and working on proving out MSW technology. I think that's something that we're all going to track very closely. I guess to stay focused on the MSW side, if you would indulge me, what do you have projected tip fees? Because a lot of municipalities are on this call as well. Do you have projected tip fees in those at least pilot projects? What you're what you think you need to charge?
Yeah, so we've already negotiated. We have term sheets with you know, multiple providers for it. I think typically in the United Kingdom, it's going to be about £85 so you know, just over, well, depending on the exchange rate these days, about $100, let's say, per ton. If you go to the continent in Europe, for example, we're typically getting somewhere around 80 to 100 euros per ton, which again is roughly equivalent to where dollars would be. I think the ranges I saw in the presentation you kindly shared, with us, I think Rob and I reflected that that's roughly the range that we're seeing over here as well. Now that's for straight up, MSW. Obviously, if you start to bring contaminated stuff into that, we're able to command a higher tipping fee, and we do have arrangements over here in that regard as well.
Thank you, Jeff. And what kind of contaminants? What's considered a contaminant in MSW?
Yeah, so that's what I think I mentioned the fossil fuel and chemical type contaminants, which we can manage through the gasification process. And in fact, we've successfully now completed trials that were third-party validated, and I'm happy to share those results with you as well if of interest. On that feedstock, because we perform very well in you eliminate that and break it down into the components. But of course, food waste as well. If you're going for a pure plastic or food waste or anything else like that, left over in containers could be seen as a contaminant. For us, it's just a part of the feedstock. If we get large quantities of it and it creates a lot of additional humidity, again, although the humidity itself isn't a problem, it could deteriorate the efficiency of the process, and we may want to get it dried. I've mentioned drying several times. Typically 15% or so would be the target, but we've just completed some trials on 30% plus humidity in municipal waste, and we had very good results coming out of that. And those will be published at the beginning of next year in French, and we will translate that. And again, that's something I can easily make available in English.
Thank you. And then really the compound question here, how long do you think until you're, do you have shovels in the ground at first of all, what would be the best plant to see MSW, pure MSW, kind of what we see in the United States as residential MSW, curbside MSW? When would the first plant be ready to be seen?
I think it'll probably be 2024, early 2024. And it will either be the one I have on this page or the one I showed previously, which is next door to Toyota. And that's 60% MSW straight up and 40% industrial waste. This one you see here would be smaller scale, but pure MSW. And this will be, interestingly, perhaps, this will be MSW to hydrogen. Because we have a grid connection, we can put hydrogen straight into the grid.
Okay, thank you. And my last question is, syngas production technology from different waste streams is something that we've tracked for years now. And I found it interesting that you took it head on, that gasification syngas production and gasification has struggled at commercial scale. Could you enlighten myself and the rest of us on kind of why that's been and what challenges are still there?
Yeah, I'll keep it brief in the interest of time. It's a great conversation. And first of all, just your first question, I just want to share your view that the future is a mixed model, right? There is no single one size fits all technology, and it's really about the challenge I know for policymakers and indeed governors is how to deploy the right ones in the right quantities in the right places. So I appreciate that challenge. In terms of what you're saying specifically, in terms of gasification, I mean, it has been the technology that hasn't worked. We have purchased a facility where the gasification technology put in there never passed its performance tests. I went there about 6-8 weeks ago, and I was absolutely amazed because you can see the hydrocarbons, that have stained absolutely everything. The inability to get to clean the syngas in a good way, but more importantly, to get a raw syngas before it goes into cleaning that has already been maximized and made as efficient as it possibly can be is a problem. And again, that's where I think our modeling capability, our control systems capability, and the real understanding of what happens inside the gasifier differentiates us. I hope that's a sufficient answer to your question for now, because it's a topic that deserves quite a lot of discussion.
No, it is, and I really appreciate your professional and transparent presentation here. I'm sure the rest of the task force does as well. And thank you, Chairman, for the time.
Thank you, Frank. I did notice that my Senate co-chair has joined the presentation, so I wanted to give Senator Needleman the opportunity, if he's available, to ask a question or address the group before we get over to Jeff.
Thank you, Joe. Excuse me, I'm a little technology challenged this morning. And I was late on, so I'm not going to waste a lot of time. But I do want to hear a little bit about the concept of the stabilization of the value of the energy, both the hydrogen and the electric. How have they dealt with that in the UK?
Well, yeah, it's an interesting topic, because I think, if I understand, Senator, your question correctly, I mean, the market, let me start with hydrogen. For hydrogen is very much supply driven right now, as we see it. There are industrial buyers of it. We are, close to a very large, actually US fertilizer company in one of our plant facilities in the UK. It's a very large facility. It uses 1% of the UK's entire natural gas consumption every year. And they've already agreed to buy the hydrogen from us. That's rare. We don't find a lot of buyers at this point in time for hydrogen. And of course, as you know, the consumer industry for hydrogen is quite a ways down the road.
Correct.
That then brings us back to renewable natural gas, which is very interesting, and we see much greater growth in, because particularly given events and, dare I say it, probably Europe is feeling it far harder than North America right now. But, the natural gas challenge in Europe is huge, and therefore anything that can replace that is there. In terms of electricity production, moving away therefore from natural gas and fossil fuel-led electricity production is important. But as is always the challenge, we have to spend a lot of time really educating. I'm in touch with the central government here and in the EU as well, because you don't know what you don't know. And so as new technologies are, this, I would argue, we've been around for 10, 12 years, isn't new, but we failed to grow as quickly as we should have done, because we're not making people as aware as they need to be, as quickly as they need to be. Am I answering your question?
Well, I guess a little bit and not. Is the value of the energy supported by any of the governments with these facilities? Is it set as a renewable with incentives and tariffs, or is it just the market? Because what you had talked about was the value of the energy being used to offset or amortize the capital cost of building a facility, which is, yes, that's part of it. Also, depending on how you value the energy and value the recyclables and all that, you end up maybe adjusting the tipping fee for the MSW.
Yes, so there are preferential tariffs for renewables, including this one. And quite crucially, and I saw the waste hierarchy that was in the paper from DEEP.
Right.
It's a very similar waste hierarchy to what we saw here. What's happening now in the UK and in Europe is that we don't fit in that waste hierarchy. They originally had us in the waste to energy space because we're taking waste and we're turning it into energy. But that was so affiliated with the incineration industry, which in many cases is not as efficient, and we don't believe is as clean as what we're able to do. What they now are recognizing is that there is another advanced thermochemical conversion category that they see as more advanced than what they call waste to energy. And they're creating a new category for that. And therefore, there will be different incentives and preferential tariffs. The flip side of that, that's interesting, is they don't believe it works.
I don't mean to interrupt you.
Please.
It's not been done yet.
It's happening now.
Okay, so we don't have any sort of data on what that's going to look like at this point.
I tell you what, I will try to get some. I will try to find if there is. They've just done an update to the hydrogen strategy and some other things, and I might be able to get some updated documentation on that.
This being done by the central government in the UK?
Yes, it is.
Okay, so it's not done sort of regionally, it's done across the whole country.
That's correct.
Okay, and just for argument's sake, and I really do apologize for missing the earlier part of this. You said the largest scalable size operation that you guys have toyed around with is what size? How many tons?
200,000
200,000. And
per year.
obviously, I'm assuming that segregating the digestible waste so it goes one way, if the facility received it in separate, however, in separate containers, it would make it a lot easier from the point of view of what happens on the tipping floor. But for a typical 200,000 ton facility, what are we looking at in terms of dollar cost for capital? Roughly.
Yeah, so the capex on that one in dollars would be probably about 200 million.
200 million. Okay. Not for nothing, but do you guys ever think about putting solar on the roof of this facility?
Absolutely. Absolutely. And in fact, that's a longer story. There are other technologies we'll put on that site that will all subscribe to the same plants as well. So it's a bit of an eco park that we're building.
Okay, great. And thank you. And thank you, Mr. Chairman, for giving me an opportunity to just ask a couple of questions.
Thank you, Senator. I don't see any more hands raised, and we are at 11 o'clock. But Jeff, you did say you had maybe a question or two for us.
Well, yes. I mean, these are probably discussive, so I might just leave them with you in the interest of time. One of them is the waste hierarchy, which I think the senator's discussion and questions really helped unpack that. I guess the other ones are slightly more, practical, down to earth questions around, what your current plans are for filling the mirror gap, as we've called it, and whether it's about extending existing incineration capacity. I can see you're exporting to landfill outside of the state, and I can see that you are, incinerating quite a lot of it. And I guess my overarching question is, what's the appetite for really some of what the senator was just asking, getting government involved with looking at new options? Is it about extending what you currently have, or is it about bringing in new technologies? And that's kind of where my overarching question was.
Well, I don't want to speak for our entire subgroup, but the fact that we had you as a presenter, and we've had other technologies come and present to us, evolving, if I want to use that term, evolving beyond incineration, although, incineration has evolved itself over time in getting more efficient and more environmentally at least conscious of what's going on. It would have to be a decision, from what I understand, that has to be made legislatively as we go forward. But we would be getting feedback from everybody on this group. I do not see our remaining and existing waste to energy plants closing anytime soon, I hope, because I think I can speak for everyone in saying that trucking out our municipal solid waste to landfills outside of our state is a major decades step backwards. So thinking outside the box, I hate using that term, but diversifying our portfolio of options is something that I think we are looking at. And I'm going to go back to Senator Needleman, who had his hand up, and then we'll go to James Elvis.
There we go. I think I figured out how to turn on the camera. I'm sorry. So yeah, I just want to confirm what the representative said, that our view here is that we want to incentivize the most efficient approach to dealing with solid waste. Connecticut was a leader for a long time, and we've moved back to this position of shipping waste out of state and burying it in someone else's state. And I think that that's probably less than ideal. And if it turns out, that that burying and landfilling is sort of the panacea that some people think it might be, then I'm not sure I'm comfortable as a policymaker saying we should ship it to another state. If we think it's the right technology, we should sort of figure out a way to take care of our own. That said, as from my own point of view, I would love to see us develop legislation that incentivizes, that creates sort of guardrails and incentivizes private industry to make the big part of the investment here. And I'm not saying that the state wouldn't participate in that at all, but somewhere in the mix of tipping fees, value of energy, most efficient technology, not necessarily locking us into one thing through policy and, passing a bill that says we will do X, is the approach here. Let the market figure it out based on the constraints, cost, and environmental benefits, the most environmentally satisfactory way to deal with this. And obviously, we all know that DEEP has a huge focus on diversion and reduction, which are an essential part of this whole process. But there will be something left, and when there is something left, we need to have the best approach to dealing with it. As policymakers, as the governor has a big stake in making a decision as to whether or not not MIRA, not that location, but a MIRA-like operation where you sort of have a quasi-public option for this that sort of sets the technological path forward, maybe, and that keeps a lid on the cost. So it's not purely free market, because these are going to be very expensive things to build and big investments. And from a policy point of view, we need to stabilize aspects of this so people will be incentivized to make those investments. The state may choose to partially own one of these or incentivize one of these and limit some of the costs to the municipalities and to the businesses in the state. That's a decision yet to be gotten to, but I think we're just sort of looking at what are the guardrails we can create to move the market forward, and then we have to have some internal conversations about whether or not there should be another public option. Obviously, the situation with MIRA did not end well, although for many, many years it was a good option and kept tipping fees under wraps for quite a while. So that's, I guess, the best answer I can give.
Very helpful. Thank you very much.
And we'll wrap it up with James Albus from our Department of Energy and Environmental Protection.
Thank you, Mr. Chairman. I just wanted to take a couple minutes to kind of respond to some of these questions at a very high level, and then respond to some other items that were discussed during the presentation. And certainly myself and others from DEEP are open for follow-up discussion if there are any additional questions that come from this. But just at a high level, Jeff, I think what we're seeing with the decision by MIRA to close their waste to energy facility is essentially a self-sufficiency gap of about 860,000 tons of MSW per year, where that is the amount that we are unable to manage within our state. It is a priority of the state to be able to manage MSW within our borders. So that is kind of the lens at which we at DEEP are looking at things. As you can see from the hierarchy, obviously there are a number of items we'd love to see more of, including source reduction, recycling and composting. That's why we have put so much effort into diverting food waste. As you can see, it's 22.3% of the waste stream. It's a significant amount. We'd like to do everything we can to maximize those strategies before looking to additional waste disposal infrastructure, understanding that that may have to be on the table. That said, the existing facilities that currently manage MSW are at or near their peak capacity. Essentially, any new waste that would go to them would be displacing waste that they're currently managing. So, just at a high level, that's currently where things are. I think in terms of where gasification falls into the hierarchy, that's dependent on a number of factors, including the type of technology that's used, the quality of the digestate, that might be retrieved from any AD processes that are part of your overall solution. What the waste hierarchy here doesn't fully illuminate is that incineration and landfilling, at least in state statute, are lumped together at the very bottom. Waste energy refers generally to energy recovery technology. So when we think about things that come up higher on the hierarchy, those are processes that have some sort of beneficial byproduct that can be composted or recycled. So don't want to speak specifically about the technology at hand, because I think we want to learn more, but that's generally how we view things in the hierarchy. So I also wanted to point out a couple of items, from the presentation that jumped out to our team. First of all, when we're talking about tip fees, the presentation that we provided last week, the tip fees included costs such as recycling costs and transportation costs. So if you were citing a facility tip fee solely, that is probably lower, or that doesn't account for all the costs that are in our tip fees. So just wanted to point that out. Also, I know our folks had some questions about, the ability to use hydrogen going directly into the grid, since the current natural gas burning technology can only handle a certain percentage of hydrogen at the moment. And we also had some questions about emissions associated with traffic coming in and out, and others. So those are some things you might want to consider as well. But anyway, we are happy for more follow-up discussion on some of these points.
Thank you, James. Very helpful. And I think it was your name on the paper that I read, if I'm not mistaken, which was very, very informative. Thank you.
Sure. Thank you.
James, thank you. And Jeff, we appreciate the presentation. We appreciate the information. Gaia will, as usual, if you provide the slideshow, she would send it out to all of us on the subgroup committee, so that we can take a little bit more time to read through and fill in our own blanks going forward. Again, thank you, Jeff. Thank you to Robert, and to our members. I'm anticipating another, potentially our last meeting on the 12th of January. And to the point that Senator Needleman brought up earlier in his discussion, the January 12th presentation will be from a modernized, more modern landfill. If there is such a thing, and we'll find out in January. But that is our next scheduled meeting. Again, everyone, thank you for taking the time to listen to the presentation, and for helping the state out as we try to navigate our path forward. And we're not going to see each other until after the beginning of the year, so have a good holiday.
Thank you very much.